In this video, I'm going to teach you a little bit about something called margin of error. Now, if I wanted to find out if the population approves of a new law, let's say a law saying that from now on, all public schools will have a school uniform. So this is the school uniform law. So they survey, let's say 100 people. And it turns out that 22% of the people surveyed approve of this new school uniform law. Now, but we don't know if we somehow could have surveyed every single person in the population. Maybe it would turn out that 22% of the entire population would support this new law. But maybe the entire population, the percent that approves might be a little bit higher than this or a little bit lower. So we need some way of estimating, what's the window? How much higher than the sample that we surveyed? How much lower do we have to go to be sure that the truth is in there somewhere? So imagine that somehow we figured out that, okay, now it might be 5% higher, or it might be 5% lower. So that would mean that in reality, if I want to know about the whole population instead of just the 100 people I spoke to, then really, if it's 5 lower, then it really might have been 17% of the population that approved. Or if it's 5 higher, then it really could have been 27% of the population. So probably the real answer is somewhere in there. Now this number that I'm adding and subtracting, the plus or minus 5%, that's what's known as the margin of error. So how do we find it? Well, there are two different ways of calculating margin of error. There's simple margin of error, and then there's a margin of error associated with confidence levels. Okay, a simple, and I'm going to use MOE to abbreviate margin of error. So there's simple margin of error, and then there's confidence level margin of error. And we'll talk about this second one a little bit later. So for simple margin of error, then the margin of error is equal to 1 over the square root of the sample size. N represents how many people you are going to survey or measure in some way. And we'll wind up adding or subtracting that when we actually do the math. Now for the confidence level margin of error, which we can be more precise, for the simple margin of error, we just find out the range where the true feelings of the population is likely to fall between those two numbers. But if we want to be more specific, if we want to be able to say we can be 90% sure or 95% sure that the true answer is in here somewhere, then we need this more advanced version of the margin of error formula that takes into account the percent confidence you want. And for that, we need certain z-scores, which we'll get into when we need it. So it's z-score. And then we've got this whole other fraction over here. So standard deviation over the square root of the sample size. So these are the two formulas for margin of error, the simple one and the confidence level one. So when I'm reading a problem, if it says anything about confidence levels, all right, if they say find the 90% confidence interval, then I'm going to use this formula. If they don't say anything about confidence levels, then I'm just going to use the simple margin of error formula right here. So let's look at this problem and see. But first we have to decide which formula we're going to use. So let's see. Find the sample size required to achieve a margin of error of plus or minus 2.45%. Round your answer to the nearest whole number. Now, did they say anything about confidence levels in there? No. So that means we're going to use the simple margin of error formula this time. Okay, so we know that the margin of error the simple margin of error, is equal to 1 over the square root of the sample size. And that n is what we are being asked to find. Now they gave us the margin of error is 2.45%. All right, the percent is important. The most common mistake that students will make is leaving off the percent. So fine, the margin of error is 2.45%. So that goes right here in the formula. So I have a choice. I can put 2.45% if I want to. That's okay. The percent is mandatory though. And then I have 1 over the square root of the sample size. So this is one way I could solve this problem. Hey, you know what? Let me teach you a shortcut real quick that comes up a lot. Guys, if you have a number equal to a fraction, so for example, if I have A is equal to B over C, okay, that was a fail, and I'm going to own that. Okay, it's electronic pens. They've got the button on the side, and I wanted pressing it. Anyway, you can make a valid equation by swapping the A and the C, the denominator and the number that's out here by itself. You can always swap that. And so that's very often useful because, you know, if I have 2 is equal to 24 over x and I'm solving this, you know, I could cross multiply or something, but the easiest thing for me to do would be just to swap these parts of the equation right here, the x and the 2. Because that'll immediately give me x is equal to 24 over 2, and then x is 12. That's just the quickest thing to do. So I learned that a long time ago, and it's not something that I find taught in classes very often, but you know, they teach us all kinds of other like shortcuts and tricks and rules. And for me, this one has been super useful. I use it all the time. Anytime I see a variable on the bottom, I look to see if I can do that swap that I was just talking about. So this is one of those times. So if I swap these out, then now I've got the square root of n is equal to 1 over 2.45%. Now that percent is important. You can't leave it off, all right? Just a word about percent. 2.45% is the same thing as 0.0245. So I can't just take away the percent, all right? Because it's this 2.45% is not the same thing as 2.45. It's 0.0245. So you can either leave the percent sign there, or you could convert it to a decimal in the first place. And I'll show you that in a second. But anyway, if you want to just use the 2.45, you got to keep the percent there. To get rid of the radical sign, you need to square both sides. So you can square this, and you can square this. Notice I'm not doing any calculations right now, because you don't want to round until the end. So keep it all just like this, and we'll just put this whole expression in the calculator at once. Okay, so that's going to give us n equals. Now just put this in your calculator. Hopefully you have a calculator as awesome as mine. All right, now I'm using the TI-30XS Multiview, as you can see. It is a great calculator. Now they've more recently come out with a new version, which is the TI-36X Pro. And that calculator is actually a little bit better. So if you can get either one of those calculators, I would highly recommend it. Now let me clear this screen. Okay, so what am I doing? I have 1 over 2.45%. The percent is important. So here I go. 1 over 2.45. And then where's that percent button? It's right there. Had to hit second to get at it. So 1 over 2.45%. And then I'm squaring this whole thing. And then there you go. We're supposed to round this to a whole number. Okay, so that means I need to cut it here. and I need to look at this next number over. If this is 5 or higher, then I need to round this number up. And so that's why I'm going to have 1,666. This has to round up. So that's going to be my answer, 1,666. All right, that's the sample size. So that's the number of people I would have to survey to get the margin of error to be 2.45%. Now, if you didn't like having the percent symbol in there, that's okay. Remember, 2.45% is the same thing as 0.0245. So you could put 0.0245 instead. Now I don't have the percent. And that means, of course, over here, I would have 0.0245 again. If you put that in your calculator, you're going to get the same thing. But what you cannot do is just put 2.45 equals 1 over the square root of n. This will give you the wrong answer. So either change it to a regular decimal, a non-percent, by making it 0.0245, or keep the percent sign on there as you do the problem. Okay, enough talk about number 7. All right, well, let's move on to number 8. The survey reported that out of 3,500 people, 76% own a smartphone. So that's similar to my last example where I was talking about, you know what, I guess I erased it. Never mind, I was talking about 22% of the people approved or whatever. So in this survey, 76% of the people own a smartphone. Now, if the margin of error is 1.7%, give an interval that is likely to contain the exact percent of people that own smartphones. So the margin of error, that's how much you have to add or subtract to whatever the survey said, you know, to find the range, the interval in which the truth lies. So I'm doing 76% plus or minus 1.7%. Okay, you want this in order from least to greatest, so you're going to want to subtract first and add second. Okay, so there you got 74.3. And of course, if you add, you're going to get 77.7%. So this is the interval that is likely to contain the true percentage of the population who owns a cell phone, somewhere between this. It's 76%, give or take the 1.7. So far, we did not need the 3,500. Let's see. If 76% of the people own a smartphone, the people surveyed, what percent of the people surveyed do not own a smartphone? Well, the total should be 100%. So all you really have to do is subtract from 100. So 100% minus 76% will tell you how many people don't own a smartphone. And that turns out to be 24%. All right, so that makes sense, right? If 76% of the people own a smartphone, 24% of the people do not own a smartphone, total of 100. Makes sense.